Okay, I'm going to do a quick recap of 5.1 and we're also going to explore 5.2. So in 5.1, we looked at reflections and we also looked at vertical, and it was either a stretch or a compression. All right. And I like to use the number line. I find that really helps me stay organized. It's a nice visual to make these distinctions. So, okay, we have a couple things that could happen when we are examining the value of A in a quadratic relation. So in other words, the coefficient of x squared, okay? If the A value is negative, okay, we know back from Unit 3 that that means that the parabola opens down. Now we know to formally identify that as a reflection in the x-axis, okay? So those quadratic relations open down, they have a maximum optimum value, and the A value is negative. That would be the first transformation you would look to identify. Okay, once you've identified whether or not it's been reflected, then we look to see if there's been a vertical stretch or a vertical compression. So anytime the value of A lies in here, so greater than 1 or less than -1, we say that there has been a vertical stretch, okay? So I'll give you an example. If we had y equals -4x squared, we would say that there has been a reflection in the x-axis and a vertical stretch by a factor of 4. Okay, and so if you wanted to just write that out with short forms, you would say reflection in x-axis and then VS for vertical stretch. This is acceptable. You can say BAFO by a factor of 4. Okay, as we move further away, the parabola gets more narrow. So y equals 17x squared would be far more narrow than y equals 4x squared. Okay. We also talked about what happens if the value of A lies in here. If the value of A lies in between -1 and 1, of course excluding 0, that would be a vertical compression. Vertical compressions make the parabola more wide, okay? So for example, if I had y equals 2/3x squared, this particular quadratic relation was not reflected in the x-axis because that's a positive number, but we would say that there has been a vertical compression by a factor of 2/3, okay? When we play around with the value of A, the location of the parabola does not change. Both of these quadratic relations, both of these parabolas have a vertex on 0, 0. What we do when we play around with the value of A is we change the shape of the parabola, and again, depending on whether or not it's been reflected, the direction of the opening. Today's lesson, okay, so 5.2, we are not going to change the shape of the parabola. Today we're going to leave the shape of the parabola alone, but we are going to play around with the location of the vertex. So there are two things that could happen. So 5.2, we're looking at translations. I don't know if you remember from elementary school, translation is just a fancy word for slide or move. So today we're not altering the shape, we are just sliding the parabola, and two different things could happen here. We could have a horizontal translation, in which case we shift the parabola left and right, or we can have a vertical translation in which we'd be shifting the parabola up or down. Okay, so let's focus on this guy first. When we are looking to see if there has been a horizontal translation, we need to look inside the brackets, okay? So for example, okay, the A value would normally be right here. It would be the coefficient of x squared. In this case, there's a bracket. Again, the A value here is an invisible 1 because today we are not altering the shape of the parabola, nor are we reflecting it. So this would be a parabola that has undergone a horizontal translation, and you would say 4 units, and here comes the most commonly made mistake, so just be careful. Remember, when you're in the brackets, you're being lied to, so it's almost the opposite of what you would think. You would think because this says -4, you're going 4 to the left, but this is actually 4 units to the right, okay? So this is a parabola where the vertex would have started at 0, 0 and moved 4 units to the right. And I will show you what this looks like on Desmos after, okay? Let's do another example. In this case, we would say there is a horizontal translation. Remember, this is just a fancy way of saying we slid it, moved it left and right. In this case, 3 units left. It's the opposite of what you would think. You would think you'd be moving to the right, but when you're in the brackets, you're being lied to. Okay, refuel with coffee. Now let's look at the next one. The vertical translations. All right, so for vertical translations, what you see is what you get, and this value comes outside of the brackets. Let me show you. So, okay, let's go kind of left to right. First thing I see here, there's no negative and there's no value. There's just an invisible 1 as the coefficient. That means this quadratic relation was not reflected and was not vertically stretched or compressed. There is no set of brackets. So this guy did not move left or right. The only thing we would say here is that there has been a vertical translation, meaning we slid or moved it up and down. In this case, 8 units up. It's exactly what you would think, okay? Let's do one more. In this case, we would say there has been a vertical translation, 12 units down. And so we are looking at each of these transformations in isolation from one another. Eventually, we'll work towards putting it all together. But now I just want to take a minute and show you what that looks like in Desmos. Okay, so I just want to conclude this by looking at Desmos. This is the graph of y equals x squared. Again, this is your basic parabola, nothing fancy. We have not altered the shape. It has not been reflected in the x-axis. We can tell because it opens up. It has not been vertically stretched or vertically compressed because the coefficient of x squared is an invisible 1, okay? And the vertex lies on the origin, 0, 0. So now, if I were to introduce this graph, okay, you'll notice that the shape didn't change and the direction of the opening did not change. The only thing that changed is that we moved this graph 5 units to the right, and so the equation for that graph would be y equals, in brackets, x minus 5 squared. Again, it's the opposite of what you would think. When you're in the brackets, you're being lied to. Okay, now, I'm just going to shift this a little bit. Okay, again, you will notice that, let's zoom out a bit here. Okay, we did not shift these parabolas up or down. Now I'm going to introduce this graph. Okay, this guy is the exact same shape as this guy and this guy. Okay, they all have the same shape. They all open up. The only difference is they have different vertices. The vertex of this quadratic relation, okay, we did not move left or right. We simply shifted down, and now we have new sophisticated language for that. So we would say this is a vertical, because it's going up and down, translation 6 units down. Okay, and the equation for this would be y equals x squared minus 6. If the value is in the bracket, that tells you you're moving left or right. If the value is outside of the bracket, that tells you you're moving up and down. Okay, let's introduce this guy. So this purple guy here, okay, has a vertex of -1, 0. We did not shift this guy up or down. We did not change the direction of the opening or the shape. So the equation of this quadratic relation would be y equals, this would be in a bracket, x plus 1, close the bracket, squared. One more example, okay? This guy, we'll kind of shift this down a little bit, okay? This vertex did not move left and did not move right. We did not reflect it, the shape wasn't altered, so this guy just shifted from the origin up 4 units. We would describe that as a vertical translation 4 units up. So let me show you what the equations of these look like, and then we'll verbally go through all of the descriptions of the transformations. Nothing to describe here. Here we would say horizontal translation 5 units to the right. Horizontal translation, 1 unit to the left. Vertical translation, 4 units up. Vertical translation, 6 units down. When the number is in the bracket, tells us whether or not we're moving left or right. When the number is outside of the bracket, it tells us whether or not we're moving up or down. Again, please notice what is in front of x squared, an invisible 1. What is in front of this bracket? An invisible 1, an invisible 1, an invisible 1, an invisible 1. Why am I telling you this? Because this lesson is only about vertical and horizontal translations. All we did in this lesson was move the vertex. We did not alter the shape of the parabola or the direction of the opening. Okay, this is the last thing I want to show you, and then we'll call it a lesson here. So if we put both of those lessons together, we end up with the vertex form of a quadratic relation. Okay, this is where all the good information is. So we talked about the value of a in lesson 5.1. The first thing we check to see is whether or not the a value is negative. If it is, that means there was a reflection in the x-axis. If it's not, then there was no reflection. The parabola opens up. Then we check to see if there was a vertical stretch or compression. We talked about the difference between the two. Remember, the further you may move away from 0, the more narrow the parabola gets. Today, we introduced this green zone here. So the next thing we look to see is we look inside the bracket, okay? And this tells us if there was a horizontal translation. Remember, when you're in the bracket, you're being lied to. So if it said x minus 6 squared, we would say that that parabola moved 6 to the right, okay? Last but not least, the fourth thing we look for is to see whether or not there was a vertical translation. And this guy, what you see is what you get. If it's positive 10, it goes 10 up. If it's negative 8, it goes 8 down, okay? Most commonly students say, well, why are these guys represented by H and K? I don't know. Why do we call the zeros R and S? Some questions are just not worth asking. I hope that helps. And again, I apologize for the quality of these videos. See you next time.